Hi guys, welcome back. We are in the series of transformers questions. Easy answer చేయడం వల్ల complicated చూడడానికి complicated గా ఉంది, though it looks complicated, but if you know the concept, you will be able to answer them very easily. Okay, so we've been looking at this series in the transformer. We are at the last session for the transformer solving. We learned a lot of concepts, we learned a lot of techniques also to answer the questions. Now, if you want more such courses, video courses, I think మీరు స్టార్టింగ్లో చూసారు కదా యానిమేషన్స్తో ఉన్న కోర్సెస్. ఆ కోర్సెస్ కావాలంటే కింద డిస్క్రిప్షన్ ఉంది కదా, courses.pi2.in. You can visit that website and you can check whatever you want. You want books or you want individual subjects, gate, online test series. There is the lowest possible price. Okay, so already at lowest possible price, so we never offer any discounts. Okay, if you want TSGENCO, you can just click on TSGENCO and you will see all TSGENCO related courses. Okay, individual courses, thermodynamics, heat transfer, electrical materials, previous year questions which will be useful for TSGENCO, and power system CL Wadwa. This is going to be amazing, guys. This will be amazing for you. This includes power system CL Wadwa, all questions with detailed solutions. Along with that, you will have few more questions. Around 1600 questions are there. CL Wadwa on 550 questions with a detailed explanation. Online test series, not video explanation, but detailed explanation will be there. Along with that, you'll have some other previous important questions. So if you can understand this package very nicely of just this much price, then I think your power systems will rock it. Okay, now let's come to today's session. Shall we start? Let's begin with the first question. Yep, starting now. Timer. Yeah, we're starting the timer. To start with the easy question, we always do the same. We always start off with easiest question, and we'll see some very interesting questions in this series. And last I think 3 to 4 questions are really amazing. You should never miss them. Okay, yeah, very good. That's nice. That's nice because the answers are very quick. I appreciate that. Okay, guys, because the question is simple, so I think you answered it very quickly. Okay, let's see once again. The transformer is not used in DC because, can just somebody tell me why? Of course, everybody is saying answer is C. What will happen? Y is clear, rate of change of flux is 0. What will happen if transformer is connected to the DC? Will it not work, or will any damage happen to the transformer? Will there be any damage? Yep. Yes. It will blast. To be more precise, the primary winding of the transformer will be damaged. Nothing will happen to the secondary. Only primary winding will be damaged. Nothing will happen to the secondary. Pulse transformer, yes. DC means here it is a constant DC. Even a pulse transformer also will be damaged for the constant DC. Okay, but time varying DC, careful guys, DC doesn't always means a constant DC like this. This is a constant DC, a special category of DC. And if you see some other things, this is also DC, time varying DC. Okay, pulse transformers are designed to work for these kind of DC or maybe pulses. Very good point. I think somebody was mentioning that. Who is that? Somebody mentioned in the chat about the pulse transformer or something. Yeah, pulse transformer for DC Sai. I want everyone punch in the name Sai in the chat for his amazing point he added. Okay, yeah, everyone. Sai, just type Sai in the chat. Good Sai. Amazing point you added to the existing point. Sir, your expression in transformer course. Okay. What is that? What was the expression? Anyways, transformer course is amazing course. I think you must have seen that. Every course will design beautiful animations with beautiful animations. Some storyline will be there for every course, for every topic. Okay, great. Moving on to the next question. Acha, expression, not expression. Experiment. Yeah, we are giving an experiments also. I didn't remember. Now I recall the experiment. The experiment was, I think you have seen the transformer experiment also. You can also conduct not just transformer, DC machines, motor also, induction motor also through experiment. We develop the transformer we developed and we have shown that experiment. DC motor we developed, DC generator we developed and we have shown you, and you can also develop the same thing. And we developed induction also, squirrel cage induction motor also we developed. You have seen that. Stepper motor, yes, we have seen. Servo motor, we have seen. Good. Nice, guys. Nanu is pretty quick in answering the question. Very good, Nanu. Somebody would like to add a point to this transformer connection at the sending end of the transmission line. We have a transmission line. For the transmission line, sending end will be which one out of all these? It is actually speaking for step up operation, out of all these combinations, this is more viable combination for step up operation. Usually if you see step up operation, delta star transformer is viable for step up operation. But we use star delta at the sending end, though we require step up here, but we use star delta, not delta star. Reason? Yes, delta star will be using at the receiving end. Very good. Sai has added Sai Ganesh to be more precise. Sai Ganesh has a nice point. Okay, so now the question is why, though it is viable and most appropriate to use step up delta star, why I'm opting for star delta? Reason? I think I said in one of our sessions. Yes, very good, Nanu. Very good, Nanu. He answered first. He added amazing explanation also. I want everyone to punch in Nanu in the chat. Nanu in the chat, punch in Nanu. Come on, guys. Come on, go on. Great. Good, Nanu. It's due to the protection. In the protection scheme, you will understand why it is so. But for now, answer is this. And Sai Ganesh has added a point. A delta star will be useful for distribution system because we need star over there at the distribution so that we'll be able to serve single phase loads also. Good, guys. Nice response, guys. Everyone, nice appreciations also. You guys are appreciating nicely. Next question. I don't have to say like the video, right? You can do that. Irrespective of whether you like it or not, doesn't cost you much, babes. Such a crook-minded person, as if it's gonna cost you too much. That's a little encouragement for everyone who is sitting over here doing the work for you. It's okay if you don't do that also. It doesn't matter for me at least. Because I know your mindset. Stupid mindset. Yeah. 5 seconds more. Time's up. Time's up. Time's up. Good, guys. We got some responses. The three-phase transformer used in distribution system may have, in the distribution system, we use, just now I said, we use delta 2 star. Delta 2 star will have a phase shift. Phase vector grouping is 1, 3, 5, 7. 1, 3, 5, 7. Not 1, 3, 5, 7. 1, 5, 7, 11. Right. Yeah. Because it's missing symmetry. 1, its opposite one is 11, right? So 1, 5, 7, 11. Okay, these are the possible combinations we can get from star delta transformer. Okay, so out of all these given options, no option is matching except option A. Plus 30 or minus 30 means vector grouping 1 or 11. I told you already. We have a beautiful session on vector grouping for free on YouTube. Just type in PiSquare Academy vector grouping. You'll get 3 videos. If you watch those 3 videos of each one 20 minutes with some amazing animations. Of course, video quality maybe is not so good, not the way you are looking at right now, because at the early stage of PiSquare, we are the first one, by the way. In 2016, I think we done that. And that time, by the way, nobody was using these smart boards and all. But PiSquare has used it. Okay. I think you have seen the smart technology what we're using right now, right? Nobody's using so far the technology what we're using. Not this, just a board. The technology behind it. In the courses, in our paid courses, we use that. I think you have seen already the promo how the courses are look like, right? So that, our objective is, what's the tagline? Tagline of PiSquare, tell me somebody. Somebody, what's the tagline of PiSquare's tagline? Huh? Nobody? I like to see from you. Someone? Pata hai? My guy is saying, sir, everyone knows it. It's lengthy, so I think taking some time to type it maybe. I believe this guy who is saying here. Yes, bridging the gap with multiplied effort, that the logo square, that itself says we are doing it with multiplied effort, which nobody else is doing. Okay. Anyways, I think this is pretty much clear. That's what, guys. We want to make it easy. The learning process should be very convenient and comfortable and joyful. Anyways, next question. Next question on the screen. Let's see how many of you are going to answer this. Wow, that's pretty quick, Sai. Very good, Nanu. See, guys, how people are, how quick people are. Time is a key aspect because the questions, it seems like there are a lot of mathematics involved here. It's not actually. It's not actually. If you know the concept, it will be very easy. Obviously, you'll have a trouble if you don't know the concept. Are you understanding the question or not? Do you understand the question? Or confused? Confused? Okay, time's up. Time's up. Let's see. Okay, they start thinking. A 400 by 200 volts transformer has a per unit impedance of 0.05. Tell me guys, is this per unit impedance referred to primary or secondary? Which one should I consider? Is it referred to 400 or referred to 200, or which side, low voltage side or high voltage side? 0.05 per unit? Yeah. Which side is that? I'm asking you. It is both. Very good. Very good. Psi, very good. Both are equal. You can say with respect to primary side, secondary side, both are equal. That's what the beauty of per unit. The high voltage side voltage required to circulate full load current means when you are conducting short circuit test. When you are conducting short circuit test, you will be connecting the meters, instruments, everything at the high voltage side. Okay. Now, how much voltage should I apply so that current will be rated current? That's the question. That's the question. So it is simply per unit times. It is obviously, man, it is simply short circuited. You have a supply. I'm not having any load. Short circuited. The only opposition you have is impedance, leakage impedance. Okay, so to drive the rated current, the only opposition is rated current. So to drive the rated current, 400 into 0.05, 400 into 0.05. So simply 4 into 5, because 2 decimals, 2 zeros gone, 4 into 5, answer is 20. So if you know the concept, answering it is pretty easy, right? Okay, concept, not too much of mathematics here. Anyways, next question. Straightforward question. I think 20 seconds is more than enough for this. It should be rather. Yes, 20 seconds is enough. Anand, good. Okay, time's up. Time's up. Let's see. It is simply said a 40 kVA transformer, 3300 volt, 240 volts, 50 hertz single phase transformer has 660 turns on the primary side, the number of turns on the secondary side. So definitely it's a step down transformer. You know, tell me guys, is this, to be more precise, this one, is this V1 or E1? Which one is this? This 3300 whatever is given here. So what is this for? Is it E1 or V1? In the chat please, quickly. Yes, it is E1, not V1. And you already know the relation between E1 and E2 is equal to N1 by N2. We derived this equation with nice experimentation and all in the course. Okay, so this is 3300 by 40 is equal to primary turns is given, which is 660 by N2. So don't think that it's too much of maths over here. It's easy. When they're giving this math, it's very easy. See, look at this, how nicely they're given it. Okay, so this is here 2 times. So N2 is equal to simply 48. N2 is equal to 48. And amazingly, everyone answered it. That's really good, guys. That's really good. Okay. Next question. Pump some hearts at least. Straightforward question. It looks a lot of mathematics here, but if you know the concept, it's very easy. Sai, check it once again. Sai, don't commit mistakes, Sai. Time's up. What happened? Sweetie, what happened? Why did you take off your answer? You took it back, your answer. What happened to you, huh? It is said the two winding single phase transformer has a voltage regulation. See guys, voltage regulation concept is the simplest concept and you will get in multiple places. Machines also and even in power systems also. In 3 places you will get these voltage regulation. And simple concept also. Concept is also simple. Okay. Not in machines and power systems also you'll get to use it. So same curve, man. Always the same curve. Curve is something like this. Curve is something like this. So this is, what's the power factor here? In the chat, please. In the chat, everyone. What is the power factor here? What's the power factor here? This power factor is unity power factor. 0, not 0 here. This is unity power factor. This is 0. This is also 0. Don't take your regular x-axis. It is voltage regulation axis. This is 0 lagging or leading here. ZPF. It's a power factor versus x-axis power factor. Y-axis is percentage voltage regulation. If you know this curve shape, the shape itself will solve a lot of questions. If you know the numbers over there, it will make much better. That's what for every course we gave the index nicely, so that like a short notes for every course. If you just follow that along, and if you follow the strategy what we have given, and it's going to be amazing for you. Okay, look at the courses, guys. What we have, the courses what we have all the courses. The pricing is just, look at this pricing. Do you think you'll ever get this pricing for this course anywhere with this amazing animations? Or if I just go to any store and have something, food, snack, just go and have some snack. Definitely it's gonna cost you 200 rupees easily. And for the same 200, you're getting complete power systems questions, 1600 questions with detailed solutions you're getting. And you will too much think about it. Your mobile recharge will cost you 200 rupees, but if a life-changing course, no, I'll not do that. Go to hell. Don't do it. Suffer. Wait, you're pushing your goal, the reaching your goal, you're reaching to your goal, you're pushing it forward. I'm not saying take this course only, take PiSquare from PiSquare only. I'm not saying only PiSquare courses are of course cheaper, but other courses also not so expensive from other institute also. Okay, so that will help you a lot. It's very good. Because of COVID, of course, there are a lot of bad things have happened, but for you guys, there is something good happen. What is that? As a lot of people are coming into this coaching, a lot of institutes have come up with this coaching, online coaching. The pricing has come down drastically. You have a huge amount of content. And if you want to use it for free, just chat in the WhatsApp, message us. I want a free video course for this particular subject. So we listed some of the available free video courses in the YouTube. You don't have to search also. We searched it, we kept it. We will forward those links to you. Okay. Because if you want for free, we can give it for free. Not PiSquare courses, huh? PiSquare course already it's best price. What are the price? You take it. If you want free courses, you cannot ask. When you're begging for something, you should beg for a food. You should not beg for a biryani, chicken biryani. Give me only chicken biryani, then only I'll take it. Go to hell. When you're begging for free, whatever you're getting, you have to take it. So give PiSquare courses for free. I have iPhone. I have money to spend iPhone. I have money to spend nice chappal, nice shirt, nice food, पिज्ज़ा खाने के लिए मैं खा लेता हूँ सर, लेकिन इसके लिए पैसा नहीं दूंगा मैं। रेस्टोरेंट के लिए पैसे दे देता हूँ, मैं कोर्सेज के लिए नहीं दूंगा। कोई इंस्टीट्यूट से मैं कोर्सेज नहीं खरीदूंगा मैं। I'll not buy any courses from any institute. then go. Enjoy. You're pushing your journey, destination little forward. You're extending the time for your reaching journey. Okay. At least start with the free videos. It is lacking. Such a simple question also you're not able to answer very quickly. Not very quickly, even after 1 minute also you're unable to answer it. Such an important concept. Then what the hell do you know about it? What the hell do you know about transformer? I'm saying it right. Losses, iron losses, eddy current losses, hysteresis losses, the relation for the losses, voltage regulation concept. These are the key concepts. These are the key concepts. Like A, B, C, D, you have to know them. Okay. Now at unity power factor, it is said it is 4.5% of voltage regulation. Definitely when you're going to the lagging, it is higher than whatever is there at the unity power factor. And if you know the formula also directly, you can say voltage regulation formula is, you'll have two terms in voltage regulation formula, per unit voltage regulation, percentage regulation, plus something, and this plus is for lagging, and this term will not be there if it is unity power factor. Only this term will be there. If it is a lagging power factor, both the term will be there with the plus sign. As long as it is a plus sign, the value will be higher. Simple. Okay. Percentage R into sin phi 2 plus percentage R into cos phi 2. Okay. Anyways, percentage X, sorry. So answer is more than 4 for the curve. Every teacher, every coaching institute will give more emphasis on this because it is important. Because it is important. Okay. Okay, guys. Anyways, let's move to the next question. Okay, Sweetie has been doing very nicely. Sweetie, it's good. This is for Sweetie, I think. Because very quick, but last question she took it back. I don't know why. Raghva, good. Divya, yeah, Divya also has been, she's been consistent. Anand Kumar, Sai, Manasa, Sangeeta. Okay, 2 more seconds to go. This is again simple from the previous question only. In a transformer, 0 voltage regulation at full load is possible. Is possible. Yes, it is possible. But it must be leading power factor only. Unity power factor, 0 regulation is not possible. Lagging power factor is not possible. At lagging power factor, it is maximum. Just now I gave the amazing curve. From this curve only, 0 at leading only it is possible. Maximum at lagging. Negative only. Leading case only it is possible. Okay. Answer is C. Sweetie has done it. Good, Sweetie. Next question. Guys, you get this book. This will be very much helpful to you. The simple book, it looks small, but almost 2600 questions are there in this. And that will enhance a lot of your understanding because it has a detailed explanation of every question. It is there in our website. Okay, right now it's not on Amazon or Flipkart. It's on our website. You can just get it. Whenever in the exams like TSGENCO, SSC guys, SSC also is coming. In 2 days, you will see SSC notification. I want everybody to apply for that. I want every one of you to apply for that. It's a central government job. Though it's of diploma standard, but you're a BTech level, you can very easily answer those questions. Very easily, believe me. Okay, all of you, you should appear that SSC also. But of course, along with that, you have to have some basics of general knowledge and all. But without that also, I think you can crack it. There are 2 papers. First paper, if you somehow finish it. Second paper, anyways, it's pure technical. It's your cup of tea. Anyways, time's up. 2 transformers are to be operated in parallel ratings. Okay. The rating share load in proportion to their kVA ratings. The rating of the first transfer rating chala sal rating rich is okay. The first transformer is 500 kVA and its per unit leakage impedance is 0.05. Okay. We have one transformer with this much rating and this much per unit. If the rating of second transformer is 250 kVA, its per unit leakage impedance, guys, kVA rating should be inversely proportional to ZPU, or it's other way around. ZPU should be inversely proportional to kVA rating. For the proper sharing of the load, proportional sharing of the load, this must be the condition with respect to their own bases. Careful, when I'm saying this, 0.05 per unit, so there has to be base. The base is 500 kVA. Now, according to this relation, here, inversely proportional relation, you don't have to do the math also here. This has become half. So per unit impedance will become double to 0.05, which is 0.1. So this 0.1 per unit impedance is with respect to 250 kVA base. With respect to 250 kVA base. So most of you have answered for C, which is wrong. Yes, C would have been right if the base would have been 500 kVA. But when he's asking about the question, 250 kVA is having how much per unit leakage impedance? So you have to understand, he's trying to ask with its own base. How will you know these kind of ambiguity? How will you know how to solve these kind of ambiguities? Just by solving more number of questions. Attempting more number of questions, then you will know the context, then you know the idea of the question, in which direction he is asking. That's only possible not just by watching, by solving. Okay. Anyways, for this answer is B. Okay. Next question on the screen. Yes, guys, parallel operation is possible. It's not about a possibility, sweetie. Parallel operation is possible for any per unit impedance. For a proper load sharing, it should be having same per unit. But with respect to common base, it should have same per unit impedance. That's what I'm trying to explain. The point what Sweetie is asking is a valid point, which I explained already. Okay, so I think definitely you can expect this question. This question you can definitely expect it. And this kind of a question about the losses, iron losses, eddy current loss, hysteresis loss. This is in induction machines also. You will see in transformers also. So high chances. Come on, guys. What happened? Sweetie, check it again. Ravya Reddy. Very good. This we took utmost care in explaining this in a simplest manner. I took utmost care in giving this the simplest possible way to get this idea. Okay, it looks complicated if you don't know the idea, but I gave you in the course clearly so that you will get a clear idea, and most of you answered it. Time's up. So if the applied voltage to a transformer primary is increased by keeping V by F is fixed. So V by F is fixed and voltage has increased. Voltage has increased means frequency also increased. Fine. Then the magnetizing current and the core losses will be. Tell me what will happen to the magnetizing current. Magnetizing current, as long as V by F is fixed, B max is fixed. B max is fixed. Flux is fixed. So magnetizing current is fixed. Okay. And anything else? If effective impedance is lost. Anyways, we'll talk about that. So it will remain the same. Increases, first it was for magnetizing current. Increases wrong, decreases wrong, remains the same. The only option left over is option D. You don't have to even check for core losses right now. Okay. Now what if you have to comment on core loss also? Then iron losses is equal to eddy current plus hysteresis losses. Bmax is constant, so hysteresis losses are a function of frequency and eddy current losses are a function of frequency square. Very good. So it seems we got wrong options. Because by increasing frequency, iron losses are increasing. Because eddy is proportional to frequency and hysteresis is proportional to, it is proportional to frequency square, this is proportional to frequency. So both remains the same, though by elimination I marked this one, but both remain the same is also wrong answer. Okay. Options should have been I mu is constant. This is, I think, one of the previous year questions in some exam, I think ISRO or something. Okay. Core losses or iron losses will increase. If Bmax is not constant, then you can say iron losses are fixed. If Bmax is not constant, then you can say iron losses are fixed. No, we cannot even say that. We can say only if, because in that case, if Bmax is not constant, then iron losses are not a function of frequency, but they are a function of voltage. Yes, then also you cannot say unless you know voltage is fixed or frequency is fixed. Unless you know that, you cannot say. Okay, so they are not under this condition. Yeah, they're not a function of frequency, means if you change the frequency alone, nothing is going to happen. But if you change voltage alone, then iron losses will be affected. Proportional iron loss will increase along with the voltage. Okay, that's good. I think we got some questions. Artificial intelligence itself is asking a question. Arey, why artificial intelligence? You itself have a lot of intelligence. But let me try. If effective impedance is asked, then it is 0.05, I think. If they are connected in parallel, no, not even that. Not even that. Eddy current losses are constant, sir. Okay, is it? Bmax is constant, so WH is also constant. No, dear. Bmax is constant. So the formula is, let's talk about eddy current loss only. Eddy current loss is equal to constant Ke into Bmax square F square T square. So Bmax is constant, means it is proportional to F square. It is proportional to F square. Okay. So here, if the primary's voltage is increased, and V by F is fixed, means frequency has to change proportionally, though it is not said frequency is changing, but the statement itself says frequency is changing. Of course, this is independent of voltage, that's true. Okay, but it is having a dependency on frequency, and frequency is also changing. You have to take it because it is given V by F is fixed. Okay. Anyways, I think you got it. Artificial intelligence. Next question. By the way, this artificial intelligence is not PiSquare's artificial intelligence. Huh? PiSquare AI will give you the answers for the questions what you asked. But this AI is asking PiSquare questions. I think we'll connect this AI with PiSquare AI, so they will communicate. Let's do that bridging communication. Time's up. Time's up. If the iron core of a transformer is replaced by an air core, answer C, D, D, C, D, D. Okay, got all answers almost in chat. By an air core, then the hysteresis losses will become 0. Because in the animation also, when I'm explaining about these hysteresis losses, in the animation also I given the magnetic reversal is happening in the dipole's iron. Their iron losses, or they are a part of core losses. Core itself is a non-magnetic core. Core itself is a non-magnetic core. So there is no saturation problem. There is no lag problem. For an air core, hysteresis curve is like this, ekdam linear, amazingly linear. So no issue of hysteresis losses. Usually, hysteresis curve will be something like this, the area under this loop is a hysteresis loss. If you have the stomach is bigger stomach, then high losses, high losses. Thinner stomach, then low losses. No stomach, no losses. No area of under this curve, no losses. I have explained this with a beautiful animation in the course. Always, any critical concept without any compromise, beautiful animations will be there. Next question. No stomach, no life. Akshita, Akshita, you're amazing, Akshita.
ఎవరురా నువ్వు ఇంత టాలెంటెడ్ ఉన్నావు?
See, we need such a kind of sense of humor. Okay, that's good. Wow, Sweetie has answered it. No core loss. Even eddy current loss also won't be there. Not just hysteresis losses. It's a simple question. Only few answers we got for this. I don't know why. Think. Time is up. Time is up. Let's see. If P1 and P2 be the iron and copper losses of a transformer at a full load, okay, so this is iron loss and this is copper loss. Fine. And the maximum efficiency, this is a full load, full load things. The maximum efficiency of the transformer is at 75% of the load. Maximum efficiency, we got it at 3/4 load. 3/4 load. Then what is the ratio of P1 and P2? Means is asking for P1 by P2. P1 is full load iron losses. This is full load copper losses. So 3/4, it simply square it, you will get it. 9/16. 3/4 square, 9/16. Simple. Or else if you want to go with a regular method, KVA at maximum efficiency is equal to KVA full load into square root of iron losses by copper losses at full load. So KVA at maximum efficiency is at 75%, means 3/4 times of full load is, let's take it as some x KVA. So full load is x KVA into iron losses full load is a P1 by full load copper losses is P2. X cancel, square comes, root comes here, square. P1 by P2 is answer. Okay, clear? ठीक है. Next question. Guys, there are 3 more questions, and those 3 more questions are really conceptual things. Stay connected, including this. Focus on this one and the next 2 more questions. They're really conceptual. Try to answer it. Let's see who is going to answer it correctly. Come on, think. Simple. Conceptual. No answer set. That's bad. Okay, at least we got some try from someone. Nanu has tried something. Okay. The next questions also stay connected. Next 2 questions also nice question. Okay, your time's up, guys. Your time's up. Let's see. In an unloaded transformer, the fluxes. Sometimes this is one of the popular questions. So sometimes they will say limiting, the fluxes limiting, the fluxes linking. The primary and secondary are 25 milliweber and 15 milliweber under no load condition. Under no load condition. So tell me, what is the flux which is linking both the coils? How much is the flux which is linking both the coils? Just answer it. Of course, some people are saying, sir, we know K, coefficient of coupling, is equal to M divided by root L1 or L2. This is a formula very well known to you. Unless you know L1, L2, M, you cannot answer it. That's what you are feeling. But my point is, you can still answer it because coefficient of coupling can be obtained through fluxes. Tell me, answer to this question simply. The question is, what is the amount of flux in this case which is linking both the windings? Both the windings. How much is a flux? How much is a flux? Come on, guys. Come on, guys. How much is a flux? M by primary flux, you're saying, Sindhusha. Okay. My question is something different. My question says, how much is the flux which is linking both the windings? If you don't know, you can say don't know so that I'll know, okay, don't know. I'll explain more about it. Respond. You don't want to respond, go to hell. Let me answer it. It is 15 milliweber. If you are afraid in the online session itself, if you are afraid to speak up, what if I'm wrong? What if I'm wrong? If you're afraid, what the hell is this? What the hell is this? 15 milliweber is the one which links both the windings. How much is the flux which is generated at the primary? It is 25. So K is also equal to this flux 15 milli by total flux which is 25 milli. Milli cancel. 15, 25 cancel. Even you will get 3 by 5. 15 by 25 is answer, which is 3 by 5 is answer. Good. Come on, it's good to accept that you don't know. If you don't know, you don't know. Simple. Simple. Okay. Anyways. Are we clear? Are we clear? Are you guys clear? Did you understand something? Okay. Brilliant. Let's go to the next question. Try to answer this. Try to answer this simple question. Guys, conceptual questions. These are the conceptual questions. If you don't know the concept, you'll not be able to answer these. We have just 5 minutes to end the session. We have 2 more questions left. Wow, Sampath is back. Sampath, we were missing you, man. Sweetie was the one who is answering. We were missing Sampath and we were missing, there are a couple of people. This is for Sampath, blast for Sampath. He has come up with a blast only because he gave correct answer with the step in itself and for a beautiful question. Not just lallu question. For a beautiful question, he has come up with a good answer. No, not a correct answer. I think Akshita is correct and Sweetie is correct. Huh? Sweetie and Akshita are correct. Anyways, let us see. Let us see the concept here, guys. Guys, pay attention. Pay attention. Everyone on the board. Look at the board. Look at the board. Look at the board. Where it has gone? It has gone somewhere. Look at the board. Got the attention here? Okay. It is first of all a transformer. In case of a transformer, negative, positive, negative sequence, positive sequence. If there is some stationary device, be it a transmission line, be it a transformer, if it is a stationary, positive and negative sequence, reactances will be equal. It is true even for transmission line. So this is wrong, either of these two is right. Now, clearly says, man, clearly says which one among these two is right. Clearly it says leakage reactance is a representation of leakage induced EMF. Leakage induced EMF, to represent leakage induced EMF, which I have described nicely in the course. To represent leakage EMF, we are using leakage reactance. To represent induced EMF, not leakage, actual induced EMF, we represent with magnetizing reactance. Now tell me, in any transformer, in any well-designed transformer, not designed by you, if it would have been designed by you and me, we would have designed a transformer with higher leakage, lower productive EMF. But in a well-designed transformer, not by you and me, because in our course, we have designed a transformer, practically the experiment. There it was not so very well designed transformer. To just let you understand the concept, I have roughly designed a transformer. In a simplest way, within 5 rupees you can design a transformer. Within 5 rupees you can design a transformer, which I described there. So their leakage EMF will be high compared to the induced EMF, but in a well-designed transformer, leakage reactance is very less compared to the induced EMF, actual induced EMF. Which clearly says this is a component representing this, this is a component representing this. Obviously, this is a higher, so this is a higher chicken flyer. That's the answer. Are you clear? Are you clear? Are you clear? Are you clear? Okay, great. Let's head to the next question then. So Sweetie and Akshita, Divya, these 3 girls were right earlier. What guys, what happened? We got a mixed answers. Huh? B, A, C, D. Surya Ganesh, Govind. This is the simplest question. For this simple question itself, we got mixed answers. When two transformers are operating in parallel, they will share the load as per, obviously, here what plays a key role is impedances. Higher the impedance, lesser the current, lesser the kVA, because voltage is same in parallel operation, voltage is same. High impedance means low current, means low kVA. So they will share the load as under. Their load sharing is inversely proportional to their impedances. Simple concept, man. Impedance is high, current is low. For a constant voltage, because it is in parallel connection, kVA is low, high, low. Load sharing, low for a high impedance. Inverse relation. Inverse relation is being followed. Next question. And the last question of the day. I think this question, I got another session. So you answer it in the chat. Okay. And then the comment itself, you try it out. Okay. So I got another meeting, so I had to rush up because it's already 8:30, 9:30. Yeah. Okay, guys. Good luck. Happy learning. Enjoy the learning in PiSquare. Bye-bye.